So good morning, welcome to Math Zone. Welcome to 10th class maths classes, 10th standard maths classes on the Pradesh and Telangana, and it may be useful for other boards also. Okay, in the last session we had a discussion. We have been discussing polynomials revision. So that means we have completed up to 12 problems. So today we shall continue remaining problems. So let me complete the remaining 2 problems. Okay. Kishore, your classes will be conducted evening, don't worry. That is okay. Right. Okay. 13th problem. So first let me write the 13th problem. If 3 and 4 are the zeros of the polynomial x square plus a plus 2 times x plus b, then find a and b. So this is the question. Okay, first read the question carefully. If 3, 4 are the zeros of the polynomial x square plus a plus 2x plus b, then find a comma b values. So how to find out these values? First of all, see first one point, 3, 4 are zeros. So that means p of 3 must be 0. In the place of x, put 3 and equate to 0. Similarly, p of minus 4 also 0. So we get two equations. Solve them. Then we get a and b. So this is the method we can adopt. So let us write the solution now. So first let us say like this. Let p of x equals to x square plus a plus 2 times x plus b. This is the given polynomial. Now since this 3 and 4 are the zeros of p of x. So that implies p of 3 equal to 0. P of 3 equal to 0 means in the place of x 3 substitute. We get 3 square plus a plus 2 times 3 plus b equals to 0. Just simplify it. What do you get? 9 plus 3a plus 6, 3 into 2, 6, open, plus b equals to 0. Now 3a plus b, 9 plus 6 is 15, plus 15 equals to 0. Take 15 this side. So we get 3a plus b equals to minus 15. Say equation 1. Now that implies even P of 4 is also 0. P of 4 is also 0 means actually what is P of x? P of x is, since P of x is x square plus a plus 2 times x plus b. So now that means in the place of x 4 substitute. So we get 4 square plus a plus 2 times 4 plus b equals to 0. Right? Lakshmi, Ganesh, are you there? 16 plus 4a plus 8 plus b equals to 0. Okay, now we get 4a plus b plus 24 equals to 0. Take 24 that side. 4a plus b equals to minus 24. Say equation 2. Right, Ganesh? Very good, Lakshmi. Solving equations 1 and 2. 1 and 2. So that means, so you write down serial itself, but I write here 3a plus b equals to minus 15. 4a plus b equals to minus 24. Subtract. If you subtract, this becomes minus, plus changes to minus, minus changes to plus. B gets cancelled. Minus 4a plus 3a. Minus a equals to 24 minus 15. 24 minus 15 is 9. So 9 write down. But multiply minus 1 on both sides. So a equals to negative 9. Now we know the a value. Okay. Now put a equals to minus 9 in equation 1. In equation 1. So in this equation, in the place of a, put 9 and find out the b value. That is 3 times minus 9 plus b equals to negative 15. Now this is negative 27 plus b equals to negative 15. b equals to negative 15 plus 27. Now the 27 minus 15. 7 minus 5, 2, 2 minus 1, 1, 12. You will be getting 12. So b equals to 12. Now we know the a value and b value. This is the a value, this is the b value. Next question. So 14th problem. 14th problem. If log 81 to the base 3 and log 8 to the base 2 are the zeros of a polynomial. That means quadratic polynomial of a polynomial. Then find a quadratic polynomial. Find a quadratic polynomial. Okay, that means actually regarding this question, log 81 to the base 3 is one of the zeros. Even log 8 to the base 2 are the other zero. So that means it has two zeros. Log 81 to the base 3 and log 8 to the base 2 are the zeros of a quadratic polynomial. Here quadratic polynomial only. Then find a quadratic polynomial. Or this question may be like this. So form a quadratic equation whose zeros are log 81 to the base 3 and log 8 to the base 2. So that means first of all, we need to find out like this. First, let us say alpha is equal to log 81 to the base 3. First, we need to find out log 81 to the base 3 value. Say next second 0 is beta, log 8 to the base 2. First, these two values we need to find out using logarithmic properties. After getting alpha plus beta, find alpha plus beta. Next, you find alpha plus alpha beta value. Next, we have the formula of the quadratic equation is given by quadratic polynomial x square minus of alpha plus beta into x plus alpha beta equal to p of x. So this is the required quadratic polynomial. We shall get it. So first let us proceed for the solution now. Write down. Let alpha is equal to log 81 to the base 3 and beta equals to log 8 to the base 2 be the zeros of p of x. First write down this step. So now alpha value we need to find out. Alpha is equal to log 81 to the base 3. So my dear students, see the 81 we can write like this. 327 ja, 39 ja, 33 ja. So that means 81 can be written as a product of the primes 1, 2, 3, 4, 3 to the power of 4. This equals to log 3 to the power of 4 to the base 3. Using power rule, this we can write 4 times log 3 base 3. Log 3 base 3 is 1. So 4 times 1. So that means 4. Alpha is nothing but 4. Indirectly given. Alpha is equal to 4. Next, now this is the turn to find out beta value. How could you find beta value? Beta value is given in terms of logarithm. That is log 8 to the base 2. So now this can be written 8 we need to write. 8 is very simple. 2 into 2 4, 4 into 2 8, 2 cube to the base 2. Using power rule this can be written 3 times log 2 base 2. Log 2 base 2 is 1. So 3 times 1 is 3. So now find that implies alpha plus beta. Alpha is 4, beta is 3, 7. Next find alpha beta. Alpha beta is equal to 4 times 3, 12. So now required quadratic polynomial is given by p of x is equal to k times x square minus alpha plus beta into x plus alpha beta. This is the formula you need to remember. Now we come to, so next, so we get p of x equals to k times x square, alpha plus beta is 7, so minus 7x here, alpha plus beta into x, alpha beta is 12, so plus 12. Actually here k does not equal to 0. You can take any k value. So now put k is equal to 1. So hence you get p of x equals to 1 into x square minus 7x plus 12. So that is x square minus 7x plus 12. So this is the answer. Next, 15th question. If cos 0 degrees plus sin 90 degrees and cosec 30 degrees plus secant 60 degrees are the zeros of a quadratic polynomial. Quadratic polynomial. Then find the polynomial. Then find the polynomial. Actually, this problem is also the connection problem, it is called. These kind of problems are very important regarding examinations. This is very important questions. But simple, this is say alpha, this is beta. That means first of all, we should know these values. See, cos 0 degrees. Cos 0 degrees is equal to 1. Even this equal to sin 90. Cos 0, sin 90 both are same. Next cosecant 30. Cosecant 30 is equal to, don't worry, 2. Even secant 60 also 2. So first we should know this one. So let us say this is alpha and this is beta. First let us find out alpha value. Next step, the beta value we need to find out. After that, find alpha plus beta and alpha beta. So then P of x is given by k times x square minus alpha plus beta into x plus alpha beta. Then we get the answer. So let us do it now. Welcome you all once again. Solution. Let alpha is equal to cos 0 degrees plus sin 90 degrees and beta equals to cosecant 30 plus secant 60 be the zeros of P of x. First we need to find out this alpha value and beta value. So now alpha is equal to, what is given instead of alpha? We have cos 0 degrees plus sin 90 degrees. My dear students, don't get any confusion. Cos 0 degrees is 1 plus sin 90 is also 1. 1 plus 1 is equal to 2. The alpha value is known now, that is 2. Okay, now beta value find out. What is beta value here? So that was given that cosecant 30 degrees plus secant 60 degrees. Don't worry, the cosecant 30 is 2, secant 60 is 2. 2 plus 2 is 4. Now this is time we need to find out alpha plus beta. That's very simple, we can find out. That means sum of the zeros. 2 plus 4 whose value is 6 and alpha beta, that is nothing but product of the zeros, that can be obtained 2 multiplied by 4 equal to 8. So now the required quadratic polynomial is given by, so that implies P of x equals to k times, this is a formula you need to remember, all of you, x square minus of alpha plus beta into x plus alpha beta. Here k does not equal to 0. K should not be equal to 0. Now here instead of alpha plus beta 6, alpha beta 8. Here alpha plus beta 6 substitute. Alpha beta is equal to 8. So good morning Vijja Swarupini. Welcome. So this equals to, we get k times x square minus 6x plus 8. So now put any value k is equal to your interest, no problem. You can put 1, 2, 3, 4 except 0. k is equal to 1. So therefore we get p of x is equal to 1 into x square minus 6x plus 8. So answer is x square minus 6x plus 8. This is the answer. So you might have understood. Once again go through the question. So note down the question. Right. Now 2 marks questions. 2 marks. So 2 marks problems. Right. In 2 marks, let us go to the 16th question. If p of x equals to x square plus 5x minus 6, then find the values of p of 0, p of 1, p of 2 and p of minus 3. So very simple question here. Very simple question this is. So this is actually the basic concept of the polynomials itself only. So here we need to find out p of 0 means at x is equal to 0, what is the value of the given polynomial. So in the similar fashion, p of 1 means the value of the polynomial at x is equal to 1. Similarly, p of 2 and p of minus 3 we need to find out. So first, this is the given polynomial. Then find first p of 0, p of 1, p of 2, p of minus 3. So let us find out now. See the solution. Given p of x equals to x square plus 5x minus 6. Now first p of 0 let us find out. P of 0. What do you mean by p of 0? In the place of x 0. Here also in the place of x 0. 0 square plus 5 into 0 minus 6. So my dear children, in rough part you check 0 square means, don't get any confusion, 0 into 0 0, 5 into 0 is 5 into 0 is 5 times 0, that's all. So here we write 0 plus 0 minus 6, 0 plus 0 0 minus 6, 0 minus 6 is minus 6. So therefore p of 0 equals to minus 6. This is completed. Now you might have got idea how to find out p of 1 also. So let us go for p of 1 value, p of 1. So now you say p of 1. So how to evaluate p of 1? Since what is the p of x value? You check it. Given that in the question, go to your question. P of 1 is given that p of x is given that x square minus 5x minus 6. So this can be written 1 square plus 5 times 1 minus 6. Okay, just one question in our mind. What is 1 square? 1 into 1, that is 1, plus 5 into 1, 5, minus 6. 5 plus 1 is 6, 6 minus 6, so 0. Here one interesting factor we could remember. So what is the factor means? If p of 1 is equal to 0, here 1 is called one of the zeros of this given polynomial. 1 is the 0. Here we are called actually 1 is the 0 of p of x. Right. If it becomes p of 1 becomes 0. So that has become 0 itself only. Now go to, let us evaluate next value is p of 2. So how could you find p of 2? Do you have any idea? So having been replaced 2 here in the place of x 2. So that can be obtained 2 square plus 5 times 2 minus 6. Simplification. 2 square is 4. 5 2 are 10 minus 6. 10 plus 4 is 14. 14 minus 6 is 8. The 2 cannot be the 0 because P of 2 is not equal to 0. So okay, leave it. Then go for the last value. We need to find out P of minus 3. So I do here. I have the space, but you write down serially itself only. Now the P of minus 3. So now you might have got an idea. How could you actually get the value of P of minus 3? So in the place of x minus 3 being replaced, minus 3 whole square. You should be very careful. Plus 5 times minus 3 minus 6. See, minus 3 square means minus 3 multiplied by minus 3. So minus into minus or negative into negative positive, 9 you will be getting. So 9 plus into minus minus, 5 into 3 15 minus 6. So 9 minus 21. So now you need to subtract 9 from 21. 21 minus 9 is 12, but we have negative. So negative 12. So in this way we can find out all the values. So understood now? This is, so we evaluated all the values. Next, let us move to the seventeenth question. 2 marks question. This is 17th question. Are you there, all of you? It's very good with just for opening. 17th. Find the zeros of the polynomial Find the zeros of the polynomial. First question, P of x equals to x square minus 3x plus 2. Second, P of x equals to x minus 2 times x plus 5. Here we have third question, P of x equals to x square minus 3. So here we have the 3 questions. Let us solve. So Monica, welcome. Very good. See, find the zeros of the polynomial. That means first question. So in the examination you may be asked to like this. One question may be given, not three questions at a time will not be given in your examination. Find the zeros of the polynomial P of x is equal to x square minus 3x plus 2. Very simple technique, very simple plan. How to find out the zeros of a given polynomial? Just simple, equate P of x is equal to 0 for in each case and solve it for the values of x. So that is the method. So then we get the zeros of the polynomial. So let us move to the first question now. First question. What is the first question here? Given, this is the first question, given P of x equals to x square minus 3x plus 2. For zeros, we have P of x equals to 0. So that implies here P of x is nothing but x square minus 3x plus 2 is equal to 0. Now we need to solve this equation. This is called quadratic equation. We need to solve it. Now the 2 into x square coefficient is 1. Factors of 2 we need to write. 2 is a prime number. This we can write 2 into 1. So x coefficient is minus 3. This minus 3 we can write minus 2 and plus of minus 1. So here minus minus. So that means the middle term minus 3x can be split as minus 2x and minus x. So let us write it. Go for the next step. So x square, this can be written minus 2x minus x plus 2 equals to 0. Now the first two terms, let us take x common. If you take x common out, you get x minus 2. From the next two terms, take minus 1 common, you get x minus 2 equals to 0. Now x minus 2 common, we have x minus 2 into x minus 1 is equal to 0. So here we get two cases. First case is x minus 2 0, or second case is x minus 1 may be 0. Take minus 2 this side. What do you get? X is equal to 2. Take minus 1 this side. We get x is equal to 1. So therefore x is equal to 1 or 2. So we can write like this. Hence, zeros of p of x is equal to x square minus 3x plus 2 or 1 and 2. This is the answer, the first answer. Shall I move to the second question? In this one, second one. What is the second one? P of x is equal to x minus 2 into x plus y. Already it has been factorized. So you need not factorize it. Directly equate to 0, and each factor need to be equated to 0. Find out the values of such x's for the respective equations. So now the solution. First given, write down what is the given data here becomes. Given equals to p of x equals to x minus 2 into x plus 5. First read the question comprehensively. The question is actually related to find out the zeros of the polynomial. That's very important. You need to keep in mind. So as you are asked to find out the zeros of the polynomial, here the polynomial is being equated to 0. So now for zeros, p of x is equated to 0. So what do you get? Obviously, we get x minus 2 times into x plus 5 equals to 0. So we get x minus 2 equals to 0 and x plus 5 equals to 0. Then what do we get? Yes, x is equal to 2 and x is equal to minus 5. So therefore x is equal to negative 5 or 2. So we can write answer. So hence minus 5 and 2 are the zeros of p of x equals to x minus 2 into x plus 5. I think you might have understood this question. Now third bit. Let us move to the third bit. Third bit is p of x equals to x square minus 3. Here, for zeros, the same process need to be applied. P of x is equal to 0. So we have x square minus 3 equals to 0. So this can be written x square and minus of root 3 whole square. 3 can be written. Here one interesting factor is that we have x a square minus b square formula. A square minus b square equals to a minus b times a plus b. This is very important formula, you need to remember. Yes, so x square minus root 3 whole square is equal to 0. We can write it as x minus root 3 into x plus root 3 equals to 0. Now we get x minus root 3 equals to 0 and x plus root 3 equals to 0. So we get x equals to root 3 and x equals to negative root 3. So hence we can conclude like this. negative root 3 and root 3 are the zeros of P of x equals to x square minus 3. This is the answer. Swarupini, check your answer. Lakshmi, Ganesh, are you there? Monica? Right. And now the 18th question. Check whether one by 4 and minus 1 are the zeros of the polynomial P of x equals to 4x square plus 3x minus 1. This is very important question. These models from your textbook also you need to solve it. Check whether 1 by 4 and minus 1 are the zeros of the polynomial P of x is equal to 4x square plus 3x minus 1. Indirectly, my dear children, you are asked to find P of 1 by 4, find P of 1 by 4 and P of minus 1. Suppose if P of 1 by 4 becomes 0, then 1 by 4 is the 0. If P of minus 1 is equal to 0, then minus 1 is equal to 0. Otherwise, it is not. That's only. Indirectly, we need to find out P of 1 by 4 and P of minus 1 only. So, let us do it now. Solution. So, this is given polynomial. Given P of x equals to 4x square plus 3x minus 1. So now let us find out P of 1 by 4. In the place of x 1 by 4 substitute. 4 times 1 by 4 whole square plus 3 times 1 by 4 minus 1. Let us simplify. So 4 times 1 by 4 whole square means 1 square 1, 4 square is 16 plus 3 1 ja 3, 3 upon 4 and minus 1. Here 4 1 ja, 4 4 ja. We have 1 upon 4 plus 3 upon 4 minus 1. Here 4 is the LCM. 1 plus 3 minus 4. 4 into 1, 4 but negative 4. 4 minus 4, you will be getting 4 minus 4 upon 4. So 0 by 4, 0 by something is 0. So therefore 1 by 4 is the 0 of P of x. This has been checked or verified. Now you move to evaluate P of minus 1, whether it is a 0 or not. So what is P of x actually? According to the question, we have the P of x equals to 4x square plus 3x minus 1. You need to remember this one. This is very important now. P of minus 1. We are going to evaluate P of minus 1. In the place of x minus 1, let us replace 4 times minus 1 square plus 3 times minus 1 and minus 1. So 4 times minus 1 square is plus 1, minus 3 and minus 1. 4 minus 4, yes, 0. So therefore minus 1 is the 0 of p of x. So there, hence we can write 1 by 4 and minus 1 are the zeros of p of x equals to 4x square plus 3x minus 1. Completed. So in this way you need to solve this question. So now let us move to the 19th question. Find the zeros of the polynomial p of x equals to 6x square minus 3 minus 7x, and verify the relationship between zeros and coefficients This is very important problem. Definitely expected question in the examination. This model you need to practice more. Okay, how could we proceed? Here first let us make it two parts. First find the zeros of this polynomial. After that say alpha and beta. Find sum of the zeros alpha plus beta and product of the zeros alpha beta. Then make the relationship between the coefficients. Okay, let us solve it now. First, given that p of x equals to 6x square minus 3 minus 7x, for zeros p of x equals to 0, this is equated to 0. So what do we get, Nana? So you get 6x square minus 3 minus 7x equals to 0. So this can be rewritten as like this: 6x square minus 7x minus 3 is equal to 0. So now you need to solve this one. 6x square minus 7x minus 3 equals to 0. First, here x square coefficient 6 into constant minus 3, minus 18. So we need to find out two numbers whose product is minus 18. Okay. Next we need to find out the sum. Minus 7 is equal to, this is the product, and this is the sum. Generally 9 to ja 18, but we need minus 7. Minus 9 plus 2 is minus 7. Here put minus into plus, minus 18 only. So that means the middle term minus 7x can be written as minus 9x plus 2x. Minus 9x plus 2x is minus 7x only. So we can write like this: 6x square minus 9x plus 2x minus 3 equals to 0. Here very interesting, from 6x square and 9x, from 6 and 9 we can take 3 common, from x square and x you can take x common, so that you can take 3x common, put the bracket, here plus 1, put the bracket, equal to 0. Here you write down 2x minus 3. Here very interesting, you get same 2x minus 3 only. So from these two, take 2x minus 3 common. We have 3 2x minus 3 into 3x plus 1 equals to 0. Now 2x minus 3 equals to 0 and 3x plus 1 equals to 0. First let us find out there its zeros. 2x equals to 3, x equals to 3 upon 2. Here 3x equals to negative 1 and x equals to negative 1 by 3. So that means we conclude that hence go back to the previous page, 3 by 2 and minus 1. Negative 1 upon 3 and 3 by 2 are the zeros of p of x equals to 6x square minus 3 minus 7x. So now what shall we do now here? It's very important step. Here, so comparing with p of x equals to ax square plus bx plus c. Now here x square coefficient is a, here 6, a equals to 6, this coefficient of x square, b equals to negative 7 and c is equal to constant term minus 3. Now my dear children, find the sum of the zeros. Sum of the zeros is generally we say alpha plus beta. This alpha, this is beta. Minus 1 by 3 plus 3 by 2 write down. Here LCM is 6. So now 3 to minus 2 write down. Plus 9. This is minus 7 by 6. Check. So minus 7 by 6. Alpha plus beta is actually here we have minus 7. B is equal to minus 7. Okay. This is plus 7 by 6. This we can write minus of minus 7 by 6. Minus 7 is nothing but B. This is A. So we have minus B by A. This is the relation of the sum of the zeros. Minus B by A or minus coefficient of x by coefficient of x square. This also we can write like this. Minus coefficient of x by coefficient of x square. Coefficient of x square. One of the relations has been established. Then go for product of the zeros. Product of the zeros. See, the product of the zeros equals to, what do you get here? Actually the zeros are what? Minus 1 by 3 and 3 by 2. So that we can write alpha beta whose value is minus 1 upon 3 into 3 by 2. Don't get cancelled. You write down minus 3 upon 6 write down, no problem. So go back. What is minus 3? See, minus 3 is constant term. See, this is 6 is A. So this we can write C upon A. So C is nothing but constant term. Upon A is nothing but coefficient of x square. So in a quadratic polynomial, now we can conclude that, sum of the zeros equals to minus coefficient of x by coefficient of x square or minus b by a. We will get it. Product of the zeros is equal to that is constant term by coefficient of x square, that is nothing but c by a. This relation will be established, is going to be established. You are asked to establish the relation also. Okay, next go for, this is 19th question. Let us go to the 20th question. Are you there, all of you? Yes or no? Have you been watching or not? 20th question. A equals to x such that x is a factor of 18. A is equal to x such that x is a factor of 18. So, and B equals to x such that x is a composite number less than or equal to 15 and n of A and n of B are the sum and product of zeros of a polynomial. Then find the polynomial. This is very, very important problem. This problem is called connection problem. This problem is connected to the sets chapter and as well as the polynomial chapter, my dear children. It's very easy. Here see, first this is set A. Set A is in set builder form. Set builder form means we need to actually write the roster form or list form of the set A. Similarly, set B is given set builder form. You need to write a list form. So n of A means number of elements present in A. N of B, number of elements present in B. So n of A, n of B is alpha comma beta, and here n of A is sum alpha plus beta. Sorry, not alpha comma beta. N of B is alpha beta. Then polynomial. Polynomial is given by x square minus alpha plus beta into x plus alpha beta is equal to 0. So that means first of all given data write down. Don't worry. Let us do step by step. Given data or given A equals to x such that x is a factor of 18. First let us find out factors of 18. What are the factors of 18? 1 into 18 ja, 2 times 9 ja, 3 times 6 ja. See, the factors are 1, 2, 3, 6, 9, 18. So this equals to, we can write like this, 1 comma 2 comma 3 comma 6 comma 9 comma 18. This is the roster form for A. Set A completed. Go to B now. What is B here? X such that x is a composite number. Less than or equal to 15. That means composite number we need to write. Venkatesh, welcome. So what are the composite numbers? Composite number 2 is not the composite number, 3 is not the composite number, 4 composite number, 5 is not, 6 composite number, 7 is not, 8 composite number, 9 composite number, 10 composite number, 11 is not, 12 composite number, 13 is not composite number, 14 and up to 15 only. You check less than or equal to 15. These are the composite numbers. So let us write in set A we have the elements 4, 6, 8, 9, 10, 12, 14, 15. So now find n of A. N of A means number of elements present in A. Count the number of elements that are present in A. How many number of elements are there? 1, 2, 3, 4, 5, 6. So that means n of A is equal to 6. N of B. Number of elements present in B. Just you count them. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in B. That is n of B is equal to 8. According to the problem we have given that we have sum of the zeros. Say alpha plus beta equal to n of A. But according to the problem, what is n of A? N of A is equal to 6. That means alpha plus beta is equal to 6, indirectly given. Now product of the zeros. See, the product of the zeros equals to alpha beta. So that is n of B. N of B means how many number of elements are present in B set? That is 8 elements. 8. Now we need to find out, hence required quadratic polynomial is given by P of x equals to k times x square minus alpha plus beta into x plus alpha beta. Here k does not equal to 0. So in the place of alpha plus beta 6, in the place of alpha beta 8 write down. So then what do we get now here? K times x square minus 6x plus 8. Now put k is equal to 1. So therefore required polynomial is P of x is equal to x square minus 6x plus 8. Okay, all of you, see you tomorrow. We shall continue the session because tomorrow is very important regarding this chapter. The 4 marks questions will be discussed tomorrow. So all of you stay tuned to our classes. Tomorrow classes will be as usual. Morning 5:10 to 5:15 to 6:15. Thank you. Bye bye. Have a nice day.